All right, well, let's do the constant and power rule. Today will be a day that you will be so happy about because you are going to be able to find derivatives without having to use the definition. You're going to learn how to do it quickly. So let's look at this constant and let's think, what would the derivative of f of x be? Well, think about the slope at any point, no matter what dot I picked along there. What would the slope of that tangent line be? And you'd say 0. So the derivative of any constant, so look at this notation. When it's written like this, it's the derivative of this thing with respect to this variable. So the derivative of any constant with respect to x is always 0. So if f of x equals 7, the derivative is 0. Even if the constant doesn't look like a constant, so you have to remember all those mathematical numbers, pi, e, those are numbers. So e to the fourth is just some number, 2.71 to the fourth. So the derivative of any constant is 0. All right, so you have that one's pretty easy. Now let's do the power rule. The power rule says, how do you take the derivative? If you remembered yesterday when we were doing these, I said, y'all, you're just going to have to trust me, because I said if we had a quadratic, then our derivative was linear. So if we had an x squared, our derivative was an x. If our derivative was x cubed, or if our function was x cubed, our derivative was x squared. The reason that I said that was because I knew the power rule, and the power rule says if you have x to some power of n, you take the n to the front, and then take the x to the n minus 1. Now I don't know if I'm going to be able to write this small in this little box, but when I do the power rule, I mean, again, there's a formula. I don't remember formulas. As you'll see when we go through this, I remember words. And there are certain words that I say in my head as I'm doing calculus. And when I'm doing the power rule, I say this: power to the front, decrease the power by 1. Almost fit it in there. So power to the front, decrease the power by 1. Let's look at x to the 8th. Power to the front. Now please note that there's really a coefficient of 1. What I'm really doing is multiplying those together because it doesn't have to be a 1. So I'm going to go power to the front, which would be 8. Now decrease the power by 1, that's 8x to the 7th. If there is a coefficient in front other than 1, you're just multiplying those together. So for 6x to the 5th, power to the front, I'm doing 5 times 6, which is 30. Now decrease the power by 1, and you get 30x to the 4th. Now, if there's more than one term, remember, really, as you know, what a derivative is just a limit. And we learned that the properties of limits, then if you had limits that were added together, I could just go down the line and take the individual limits and add them up. Well, it's just, if a derivative is really a limit, I can do the same thing. So if I have a long polynomial, like I do here with 3 terms, to find f prime, I'm just going to go down the line and take the individual derivative of each thing. So I'm just going to look at 2x squared. Power to the front, 2 times 2 is 4, decrease the power by 1, that would be x to the first. I usually don't write to the first, but if you did, it's okay. Now go down the line. What's the derivative of 3x? That's really 3x to the first. So power to the front, decrease the power by 1. That would be x to the 0, which is 1. So I just get the 3. You can also think of it, again, if you have 3x, that's a line like this. Remember, that is a constant slope of 3. So the derivative of 3x is just 3. Then I look at the 6, or negative 6 rather, but we know that the derivative of any constant is 0, so that just drops off. So my derivative is 4x plus 3. Are we so happy? Yes, we are. We do not have to do the definition of derivative. We can just get these derivatives very, very quickly. So on your test, listen, definition of derivative is tested. The only time you have to use that is when it says, use the definition of derivative. When you see that, you have to use the definition of derivative. But any other time, I want you to find the derivatives in a fast way. So let's keep looking at different examples, because although it's not, the power rule in itself is not difficult, but there's sometimes a step before the power rule that you can do. So let's look at these. So we're finding the derivative of everything, of course, but let's look at this one, 1 over x squared. Well, I'm telling you that you cannot take the, well, excuse me, you can take the derivative of a quotient, but there's a big rule to it. So if there's a way to write this, and we don't even know that yet, so we can't do it yet. If there's a way to rewrite f of x, you'll need to do that first. What I mean is, instead of writing 1 over x squared, I'm going to write this as x to the negative 2. That's the same thing. The power rule does work on negative exponents. So my derivative, f prime, power to the front, negative 2. Now be careful. Decrease the power by 1. Now look at the formula. I say decrease the power by 1. You take the power minus 1. So if you decrease negative 2 minus 1, you end up with negative 3. And in the same way that you kind of had to rewrite at the beginning, you usually have to rewrite at the end, because on multiple choice, they won't leave negative exponents. So instead of writing negative 2x to the negative third, they would write that answer choice, so you need to practice doing this, as negative 2 over x cubed. You don't move the negative 2 because it's not being raised to the negative exponent, but you do have to move the x cubed. On number 3, why don't you try that one? Try number 3 real fast. It shouldn't take you that long. I'm just going to write that first term a little differently. So how would we write the derivative? Remember when it says y equals, do you remember the notation? I wouldn't put f prime because my function wasn't given as f. Remember what the derivative looks like when you're given y is dy dx equals. And I've seen y prime before, so if you wrote that, I would give you credit for that. But I just want you to make sure you know what dy dx is, that means the derivative. The derivative of y with respect to x. So here we go. I'm just going to go down the line. 4 times negative 1/2. 4 times negative 1/2 is negative 2. Decrease the power by 1. Power to the front, 3 times 3 is 9. Decrease the power by 1, that's squared. And then negative 2x is just going to be negative 2. And there's my derivative. Lovely. Now look how much nicer our life is with this question. This question is not a new question. Write the equation of the tangent line to f of x at x equals 2. Well, here's the beauty of now taking the derivative quickly. This problem just went from about a 3 to 4 minute problem to about a 1 minute problem. Because you don't have to do the definition of derivative, you can get the derivative very quickly. But what should be on my paper? What work should you show? If you're writing the equation of a tangent line, remember you need a point. I always find that first. So f of 2. So I'm going to plug that in. Again, do you have to show the work? No. If you can do it in your head, that's fine. I just don't want to mess up. So 2 to the 4, 16 times 2, 16 times 2, 32, plus 35. So my point is 235. Then I need the derivative at 2. I need f prime at 2. But I don't have to do the limit statement. I'm going to just go ahead and find f prime of x. Notice I label it though. Everything has a label. Get in the habit of doing your labels now. Power to the front, decrease the power by 1. There's my derivative. Now I need to plug in the 2. And I think that one I'll do in my head. 2 cubed is 8. 8 times 8 is 64. There's my work, and now I do. Here's my point. Here's my slope. It did say tangent line. I always read it again, making sure it doesn't say normal line, because I'd hate to miss it because of that. I'm going to go y minus 35 is equal to slope x minus 2, and I stop there because I'm going to leave it in point slope. So I'm so happy that those problems are now not as difficult as they were before. Why don't you try number 5, example 5. Well, this one's asking the same thing. Write the equation of the tangent line. And so I'm going to do, I'll go ahead and do f of 8 because I usually start there, f of 8. So if I plug in, that's 1 over 2 times 8 to the 2/3 power. Remember how you do that, or how I like to do it, is I do the root first. So the cube root of 8 is 2. 2 squared is 4. 4 times 2 is 8. So I end up getting 1/8 for my y value. So my point is going to be 8 negative, I don't know where I get negative, 8 1/8. There's my point. Now for the derivative, I need the derivative at 8. But I will tell you, I certainly need to rewrite f of x because, again, I see that quotient. And a lot of times people mess up on the rewrite. What is f of x? If I wrote that, everybody try to rewrite f of x. And be careful because a lot of people put this. They put, oh, the 2's on bottom, so 2x to the negative 2/3. That's not right. The 1/2 does not change. So I need to make this one-half. So my derivative, f prime, is going to be power to the front. I'm going to write this one out. 1/2 times negative 2/3 x to the negative 5/3. What does that look like? Let's clean that up. That would be negative 1 over 3. And I'm going to go ahead and put that 5/3 on bottom. That's at the bottom of the fraction. So what would f prime of 8 be? Well, let's see. What would 8 to the 5/3 be? That would be 2 to the 5th, the cube root of 8 is 2, 2 to the 5th is 32. So, kind of gross number, but you can do it. What is that, 96? So my answer, again, it's asking for tangent line. Y minus 1/8 is equal to negative 1 over 96, x minus 8. Remember, if it does ask for the normal line, I would do all the same work, but I would have chosen a slope of 96 right there. Positive 96. All right, we got one more example to do. One more example. Determine the points or points at which that function has a horizontal tangent line. Now, what does that mean? Horizontal tangent line. F has a horizontal tangent line if what? The derivative equals 0. So I need to find the derivative of this thing and set it equal to 0. However, remember me talking about when you have a quotient, you can't just take the derivative of the top and the derivative of the bottom and divide them. So what do? Right now, you have to get rid of the quotient. You have to be able to rewrite it. So since you have divided by x, isn't it true that f of x, if I just divided by x, I would get 2x squared minus 3x plus 1. I could just kind of do it like that. So the derivative, well, now that's easy. The derivative is 4x minus 3. And you told me that I have a horizontal tangent when, I should say f has a horizontal tangent when f prime is equal to 0. So I'm going to set f prime equal to 0, and I'm going to get a value of 3/4. Now you have to read, because sometimes in these problems it says determine at which x value f has a horizontal tangent. Well, unfortunately, if it had said that, I'd be finished. But this said the points, which means my answer is going to be this. F has a horizontal tangent at 3/4, comma, something. I have to get that y value. So where do I get that y value? Well, I have to plug back in to f of x. And yes, you have to deal with fractions. So let's do it. Well, we can simplify it as we go. F of 3/4, everything has a label. I'm going to do 2 times x squared. So if I square that, that would be 9 over 16. Minus 3 times 3/4. Remember, I'd multiply straight across. So that would be 9 over 4 plus 1. Now the good thing is, might help me, I'm going to change this to 9 over 8, because that's really what that is. So let me just get everything with a denominator of 8. So this guy wouldn't change. This would have to be multiplied by 2, so on top would be 2, so that's negative 18. Of course, I would change that to 8 over 8. So 9 minus 18 plus 8 is negative 1/8. And that is my y value. And so I have a horizontal tangent at 3/4, comma, negative 1/8. So there you go. Enjoy the power rule. Enjoy being able to get derivatives quickly. Make sure you label everything as you're doing these problems, and you will be good to go. All right. See ya. Peace out.